Hello, and thank you for joining us for today's event. What is the future for internal combustion engines and fuels in a reduced carbon world? During this event, all participants will be in a listen-only mode. To ask a question at any time, please submit the question via the chat box located in the lower right-hand corner of your screen. You may direct the question to all panelists. We encourage you to ask questions at any time during the presentation. Your questions will be addressed when possible. As a reminder, this event is being recorded. The recording will be available on the Diesel Technology Forum's website shortly after the live event. I would now like to introduce our moderator for today's session, Alan Schaefer, Executive Director of the Diesel Technology Forum. Alan?
Thank you, Josie, and good afternoon, everyone. It's delightful to see all of you here today. We have an expansive audience from all corners of the globe, so it's nice to see that diversity. And we look forward to spending the next hour and a half with you to talk about this very important topic about the future of internal combustion engines. First, I want to recognize that today's session is made possible by the members of the Diesel Technology Forum. And we have a number of those companies participating on today's call, including Cummins, Neste, and Tenneco. So thank you all for that, and Deere. Thank you all for your support and appreciate your participation especially. I want to just begin our discussion today by framing the moment. We are in a world of transition in terms of energy. We are reliant heavily on fossil fuel energy, but also trying to make a move towards using more renewable energy, both in the kind of energy that powers our homes and powers our vehicles, machines, and equipment. The internal combustion engine is seated squarely in between these two worlds. And that is the subject of our discussion today. The how, why, and where diesel fits, internal combustion engine, including diesel and other types of internal combustion engines, how they fit in this future going forward. There are, as you all know, I'm sure, many global policies and pledges that are in place now that are impacting future fuels and technology. And this slide just lists a few of the major ones, including the Paris Climate Accord and some more specific commitments that have been made by the US government. These have led to a major emphasis on electrification and technologies that could replace internal combustion engines in some sectors. But there are many uncertainties here for this kind of transition, including geopolitical concerns and others listed here. There are also many questions about whether or not these kinds of transitions can take place in the time frames that have been identified. And then there is a question about whether or not alternatives to internal combustion engines truly are zero emissions technologies. And that is the subject for us today. The future for internal combustion engines is one that's going to be determined by a whole range of developments. One of those is they have seen some government activity that has proposed banning or adopted bans on future internal combustion engines used in passenger vehicles and some commercial vehicles in some countries and even in some US states. On the other hand, there is a fairly strong prediction that the global internal combustion engine market is going to grow throughout the rest of this decade with a fairly aggressive growth rate. That owes to the nature and importance of the internal combustion engine in powering our global economy today. So we want to know how, where, and why will internal combustion engines and fuels contribute to helping achieve some of those goals that are outlined on the initial slide. And that's the focus of our discussion today. Our session will be broken down into three pieces. We're going to hear a keynote presentation in just a moment. Then we will get into a discussion about the markets, technology, and fuels issues around internal combustion engines. And then we'll finish up with a discussion about policies and address these and other questions related to that. I want to thank all of our participants today, and I will be introducing them as they begin their speaking engagement. But we have the great benefit of leaders in technology, in consultancies, both on the energy side and engineering side. And I'm really excited to hear the different perspectives that you're going to get in the next few minutes. So without any further ado, let me start off by introducing our keynote speaker. And for many of you, Dr. Kelly Senecal will need no introduction. Kelly is co-founder and owner of the Convergent Science, a company that specializes in helping manufacturers and those in the engine business understand how those engines work and how they might work through some very sophisticated analysis and technology, and really some cool stuff, as I like to say. He is also adjunct professor at the University of Wisconsin in Madison and a visiting professor at Oxford. He's a fellow of the Society of Automotive Engineers, SAE, and he is co-author of Racing Towards Zero, The Untold Story of Driving Green. And you might also know Kelly from some of his more popular social engagements and discussions, most notably Hug Your Engine. So Kelly, we are delighted to have you here today. Thank you again so much for kicking off our session, and I'll turn it over to you.
Okay, great. Thank you, Alan. I assume everybody can see my screen and hear me okay? Okay, perfect. Thank you so much. I am thrilled to be here today with all of you. Very excited about the large turnout, large registration count that we received for this. And I'm actually really excited to be here with the panelists. I think we're going to have an excellent discussion on the topic that Alan described. What is the future for internal combustion engines and liquid fuels in a reduced carbon world? Now, I'm going to turn that question around a little bit and first kind of ask maybe a bigger question. Is there a future for internal combustion engines and liquid fuels in a reduced carbon world? Now, Alan already alluded to this, but I'm going to talk a little bit more about, the bans that we're seeing being announced around the world. So if you believe that these bans will happen in the future, currently most of them are being discussed around cars, but those could expand into other areas as well. Here's a headline that came out this summer. EU lawmakers endorse ban on combustion engine cars in 2035. It looks like they're at least planning on moving forward with that. Even here in the US, California will ban sales of new gasoline-powered cars by 2035. At least that's the goal. And as you know, in the US, there are many states that kind of follow the California rules when it comes to transportation. So this will be interesting to see how this plays out. So if we put this on a map, and this is a little bit outdated, this is a couple of years old now, but if we look at, across the world, what announcements have been made for various years, right? Anywhere from, move this out of the way, anywhere from 2025 all the way to 2050 plus. And if we add these very recent announcements, apologize, I'm not an artist here, but I tried to color in Europe and also California in yellow, where the 2035 announcements have been made. So it'll be interesting to see how this plays out, but this is kind of the world we're living in right now. So again, asking the question, is there a future for internal combustion engines and liquid fuels in a reduced carbon world? Many people might look at this and say, doesn't look like it. I say yes, very emphatically, I say yes, and you'll see why in a moment, and you'll hear why from all of us today in the panel session. Okay, my thoughts on this topic. I believe we're making a big mistake in the transportation sector, including passenger cars, with the singular push, or what appears to be a singular push by many, toward battery electric vehicles, or BEVs for short. If our goal is to reduce transportation carbon emissions as fast as possible, hybrids and also renewably fueled internal combustion engines must make up a significant portion of the fleet, along with BEVs, for years to come. And I feel that instead of pushing a silver bullet kind of solution, government and industry should educate, promote, and incentivize a diverse set of transportation technologies. Because as we'll see today, and as we'll discuss, the best technology depends on location and application, and also budget. And my slides here at the beginning will be a little bit passenger car, light duty focused. I did that intentionally because we're going to be hearing a lot about other markets and other applications throughout the panel. And passenger car seems to be the one area where people think that ship has definitely sailed and we're going to be going all electric. And so I kind of wanted to make the case that I don't agree with that. So how did we get here? Well, we've already talked about it, right? We have electric vehicle. This is great technology. It's vastly improved over the years. The technology itself at a fundamental level is as old as the internal combustion engine, arguably older. But in the last couple of decades, maybe decade or so, we made a lot of progress. Tesla's made a lot of progress. The other OEMs have made a lot of progress. And really, this is becoming now a viable, or has become a viable way to get from point A to point B, especially for light duty. The other reason why we're here is, of course, I don't need to say too much about Dieselgate to this audience, but the Dieselgate scandal kind of gave the internal combustion engine in general, not just diesels, but in general, kind of a bad name. And we're really kind of hyper focused on tailpipe emissions, right? And that makes sense because historically, most of the cars or any sort of transportation vehicles that we've used have all used internal combustion engines. The majority of the emissions come out of the tailpipe. Okay, advance this. Okay, there we go. So what is the problem now? So I would argue we've introduced new vehicle types, BEVs, even fuel cell electric vehicles, without proper methods to account for the environmental impact of driving them. So the regulations are typically based on tests measured at the tailpipe, but as you know, zero emission vehicles have no tailpipe. So what this effectively does is it makes the CO2 problem someone else's problem. It's no longer the transportation industry's problem. Zero emission vehicle, again, in the light duty world at least, is counted as zero CO2, and it's sometimes even counted as more than one zero CO2 vehicle. And what that allows people to do is sell these zero emission vehicles and then effectively sell more large, low fuel economy vehicles because of the way we do the fleet averaging. So this is kind of a head scratcher. It's really reducing our greenhouse gas emissions at the end of the day. Sometimes yes, sometimes no. But really the way I believe we should be looking at this problem, instead of looking at just the tailpipe alone, is something called life cycle analysis. Okay, so what is life cycle analysis? Kind of very briefly here. Typically when we regulate cars, at least, we look at the use phase. So here's a car, imagine it has a tailpipe. What are the emissions coming out of the tailpipe, right? When you have a vehicle that you need to charge from the grid, we should also be including the electric power generation and distribution, right? Because as we know, when you charge your vehicle, that is creating emissions typically, just not where you're located. What about producing the vehicle and the battery? Very carbon intense to produce these large battery packs. Disposal and recycling, and extracting and processing raw materials. So these are all the different phases of life. This is sometimes called cradle to grave, right? All the way from extracting the materials needed, the production, using the vehicle, all the way to disposal and recycling. All of these things have an impact on your true driving emissions, and all of these should be considered. So with LCA, it's very promising if it's done correctly, but it's currently not part of any regulations. And it's mainly being used for academic purposes. It's also used to inform future policy, at least that's the intent. Assumptions, there are a lot of assumptions that go into life cycle analysis. If you're familiar, you'll know what I'm talking about. A lot of these assumptions are often made to favor battery electric vehicles, whether intentional or not. I think a lot of times it's not intentional. Often we will compare to traditional internal combustion engine vehicles and not hybrids. We know that adding a battery pack to adding an electric motor and a battery to an internal combustion engine allows it to be more efficient. That's something we should probably be doing on every vehicle. An average total electricity mix is used to calculate the charging emission rates, and then overly optimistic projections are used for the future electricity mix. So here's an example. This is a study from the ICCT, which I like to look at because it kind of shows the different issues, I would say, that are out there for these LCAs. One is, they compared an ICEV to a BEV. There is no hybrid. They've looked at hybrids in other studies, but in this particular study, there are no hybrids shown. We know hybrids would do significantly better than the ICEV. They're also using an average electricity mix for the entire United States, and I'll show how I think that should be done in a moment. And then they are making projections about the future electricity mix, which is true. So how should we compare vehicles using LCA? So I'm not going to go into the details, but I invite you to check out a recent study that we put out with one of the SAE journals. It's called a Data-Driven Greenhouse Gas Emission Rate Analysis for Vehicle Comparisons. And this allows us to do comparisons of, say, battery electric vehicles versus full hybrid electric vehicles. So if you're not familiar with the lingo, full hybrid means you don't have to charge it from the grid. You're not plugging this in, right? It's just a regular kind of full hybrid. Okay, so how does this look? And if you notice, I don't just have a single bar graph for the entire United States because I'm not using the average electricity mix. That would lead to big errors, I think, in the comparison. But what I'm doing is looking at this locally, right? And what we know is the United States is a big country with, very different conditions, very different grids throughout the country. And if we look at this over a map of the United States, what you'll see is here, anything that's red or pink shows that driving a full hybrid is more favorable to greenhouse gas emissions, produces fewer greenhouse gas emissions per kilometer driven. Anything that's black or gray favors the BEV. And the reason why you see 4 plots here is because there are assumptions that go into this. And really, it's not right to look at one exact condition and draw a conclusion. You have to look at a range of conditions because there are uncertainties in these things. But what you see kind of overall, pretty overwhelmingly, is for this vehicle comparison, which is a small SUV, pretty popular kind of vehicle size in the US, driving the full hybrid actually is better for the climate than driving a battery electric vehicle. Okay, so what are my recommendations? And we'll talk a lot about this throughout the panel session today. But I feel like we should take a balanced approach to transportation, recognizing that there is no silver bullet solution. I don't agree with any bans. We shouldn't be banning any particular technology. We should set targets and let the best technology win, understanding that the best technology will likely vary depending on where you are in the world or even where you are in the US. Use life cycle analysis when comparing technologies, including only the tailpipe emissions or even just the use phase where maybe you are including the charging. That can still significantly misrepresent a technology's environmental impact. I believe we need to continue to invest in internal combustion engine technology. Counter to popular opinion, there is still room for improvement. We should be devoting significant resources to investigating carbon neutral fuels, and you'll hear about this today in the panel. This allows us not only to make use of the current infrastructure, right, but what do we do about the existing fleet? Even if we were to turn over all the vehicles to battery electric, say, all the new vehicles, there's still a lot of vehicles that are going to be on the road for years and years to come. So we need something to help us decarbonize the existing fleet, and these carbon neutral fuels or low carbon fuels allow us to do that. Hybrids are actually the fastest way to reduce CO2 emissions from vehicles. We should be treating them that way. I don't have time to go into that table, but I'd be more than happy to answer questions later on that. And then kind of overall engineering, not politics, should drive future transportation policy. So if I'm going to leave you with a couple of items here, one is combustion and decarbonization are not mutually exclusive. We need combustion, we need the internal combustion engine and its fuels. Hopefully we're moving away from fossil fuels as fast as we can, but we need this to help drive decarbonization or defossilization. And then finally, I'm going to leave you with a question that my son asked a few years ago when he was 13. He had to do a science report, and people think I had a major influence over this, but he would not let me look at this at all. I just happened to snap a photo when he left it on the kitchen counter. And his question that he was going to answer in his report is, what is the most climate friendly today, a car with an electric motor or a car with an IC engine? And I think his answer is very appropriate. It depends. I think we all need to keep that in mind. With that, I'd like to conclude. And as Alan said, if you do want to kind of see more of what I have to say on this topic, please follow me on LinkedIn or check out my book. I'm not trying to plug my stuff here, but I think I have a lot to say about this topic, and I'd be happy to engage with you. Thank you.
Kelly, thank you very much. That was a very inspirational to get us started. Lots of issues there, and we are going to jump right into that with our panel today. Let me have the pleasure of starting our introductions with Dr. Kathy Choi. And you can see Kathy's bio here. She's an executive director at Cummins, responsible for product development and technology strategy. Many years experience in corporate R&D and production, and she is a great voice for Cummins and their path forward. So Kathy, thank you for joining us today, and let's hear from you.
Thank you, Alan. I am excited to be here with my esteemed colleagues to talk about, on this panel, to talk about the future of IC engines. Next slide, please. As Alan stated, my name is Kathy Choi. I am from Cummins, and it is our mission to make people's lives better by powering a more prosperous world. We will achieve our mission by embracing over 100 years of experience in global power production. We employ nearly 60,000 across 190 countries, including 26,000 here in the US. Cummins We invest over $1 billion in research and technology, and what that results in are power solutions for diverse applications. And those solutions include engines, generator sets and their associated componentry, and new power products of battery and electric powertrains, fuel cell systems, and hydrogen production. So that is a snapshot of Cummins, but what I'd like to talk about is really what our goals are in the future. Next slide, please. So Destination Zero, that's the name of our strategy, of the Cummins strategy to achieve zero emissions by reducing greenhouse gas and supporting the transition to decarbonized power. Destination Zero, it lowers emissions today by continuing to advance the internal combustion engine and reducing its greenhouse gas while investing in new technologies. So what this does, it allows us to progress even while infrastructure is being put in place. Destination Zero also incorporates well-to-wheel emissions reductions by matching technology readiness with infrastructure readiness. It also drives wide-scale adoption due to affordability by using the right technology at the right time. Whether our target is to reach that Destination Zero emissions by 2050. Thank you for your attention.
Great, thank you for that opening and getting us started on the panel, Kathy. Next up, we have Pierre Gaillot, who is the Senior Vice President for John Deere Power Systems. And Pierre is coming to us today from Paris. Thank you for joining us, Pierre, and we look forward to hearing from you.
Thanks, Alan, and good morning, good evening, good afternoon, everybody. I'm very excited to be here. As Alan said, I'm the Senior Vice President at John Deere Power System, and as you can hear, I'm French, so please bear with my accent, but I will do my best to be understandable. So next slide. So John Deere Power System is a part of John Deere. We are vertically integrated for engine, drivetrain, and battery. So we propel our 100,000 engine around the world. We produce engine from 2.9 to 18 liter in South America, North America, Europe, and India. And next slide. And John Deere, as you see, is present globally in every part of the world. We have more than 100 locations. We are from the earth of farming in Illinois, about more than 75,000 engine, a 52 billion company. One statement I want to open with is we are fully committed to sustainability. John Deere is 185 years old, so we know what sustainability means. We know what reliance means. And we are very committed to help the world to flourish, specifically the people around farming and construction, by committing the reducing our CO2 emission by 30% by 2030. It's a big challenge for us, but I think both our equipment and our customer can play a significant role in helping the world to go into a low carbon environment. So looking forward to our conversation. I think it's an exciting time we are in, and when an industry is transforming, if people like a large multinational, we have a big role to play to enable that.
Excellent, thank you, Pierre. Next up, Dr. John Pinson. John is the Chief Executive Officer at Stanadyne. He's served there since 2022, but has been with the company for a bit longer. Has a very long and distinguished career in global emissions compliance strategy and engineering, first at General Motors and then other places. So Dr. Pinson, thank you very much for being with us today.
Thanks very much, Alan. If you could jump to the next slide. So just in brief, Stanadyne we are primarily invested in fuel injection systems and emissions compliance solutions that are based on those systems. And we firmly believe, as some of the others have stated already, that one of the most important things we can do now is to improve what we have, the internal combustion engine. And we see that as a major contributor to our near-term and far-term success. And so we think of this as how do we enable clean propulsion through engine innovation. So, we see this happening really, there's three different dimensions of that for us. One is how do we bridge the gap to zero carbon starting from where we are right now? And this is a common theme that we've heard already from the other presenters is we need to reduce the internal combustion engine carbon emissions now. And that's particularly important because there are many applications which are not front in line, but which are major contributors to the emissions scenario that we're trying to deal with. And we think that the primary route to innovation there is high pressure liquid fuel systems. That's been the case as we looked at gasoline and diesel and now alternative fuels, et cetera. And we also expect that the regulations will catch up with this much sooner than the availability of some of the technologies in electrification do. So really, I see the focus now is in this area. But as we move forward, some of the internal combustion engines are going to be quite difficult to electrify. And we need to work towards strategies of decarbonization of those applications to have them join their electrified brethren in low or zero carbon. And this can happen in a number of different ways. The low and zero carbon liquid fuels are going to be important. I think there'll be some gaseous fuel penetration, which will include in selected applications, hydrogen, and then also design for remanufacturing or sustainability of the overall engine. Today, a lot of energy is invested in making these. Technology is changing very rapidly. And we believe that there's going to be a need to remanufacture, repurpose, restore, perhaps even upgrade power plants as we go into the future so that equipment on which we are applied can stay in service much longer and keep track with the compliance and regulatory progress that we're making. And then the last point I want to cover here in this introduction is that we're present globally, and we recognize that local solutions are required. Local markets are going to transition at differing paces, and also the availability and access to low carbon fuels and other alternatives, infrastructure is going to differ by market. And so to move to our end goal of reduced and eventually zero carbon footprint in our industry, we're going to have to take these differences in markets into account. So thank you. I'm really looking forward to participating in today's discussion.
Very nice. Thank you, John. Next up, we have Matt Luke. Matt is the technical manager for Neste's renewable road transportation business. Matt has been in the industry a long time, and we see him everywhere talking with users and policymakers and others about this great renewable diesel fuel product. So Matt, thank you for being with us today.
Yeah, definitely. Thanks for having me. And, there's engine OEMs and hardware providers and stuff here. So coming from the fuel side, it's exciting to be on this panel. Just real quick about Neste as a company, we're based in Finland. We're the Finnish national oil company after World War II. So we've been in the fuels business for a long time. And we developed the renewable diesel, the hydro treating kind of technology, patented back in the mid 90s and started producing in 2005. We're currently the world's largest producer of renewable fuels. Right now, we have a goal of helping our customers reduce emissions by 20 million tons by the year 2030. Last year, we did 10.6. So we're definitely on an upward trajectory to hit some of those goals. Kind of like Kathy mentioned at Cummins, we spend quite a bit of money on R&D for future technologies and feedstocks and things. And all that basically is allowing us to grow our footprint around the world. Those numbers you see here on the right side, that 3.2 and 6.8, let's jump to the next one. I'll show you what that looks like. We have 5 refining units in 4 locations around the world right now. So Porvoo is just outside of Helsinki, where we're based. That was where we first implemented this technology. Singapore and Rotterdam are kind of sister facilities. And then you guys may have heard about the joint venture we announced with Marathon Petroleum in Martinez, California. That'll be coming online early next year. So basically, we're going from, right now around 3 million tons of product a year, which is around 1 billion gallons. By 2026, we're aiming for 6.8 million tons, which gets us to just about 2.8 billion gallons. So going a long way to that 20 million ton reduction goal per year for our customers. Later in the presentation, we get into more of the nuts and bolts, but that's kind of what we're here for.
Great. Thank you very much, Matt. That's a massive increase in volume and a necessary one. Next up is Troy Cantola from Tenneco. And Troy, I'm really delighted to introduce you as someone who has been married for 39 years and is a father to 4 sons. That says a lot about your capabilities, even beyond your role as product director there at Tenneco. But thank you for being with us today.
It's a pleasure to be here. I also am humbled to be on this panel. I'm excited to address some of these questions that we have scheduled. Let's go to page 2, please. Tenneco is a company that's been in production for component parts for OEMs in the aftermarket. If I trace it back, it gets to about 135 years. Presently, today, however, we're 71,000 employees. We all have children, we all have grandchildren, and we're all concerned with our impact on the biosphere, whether it be our corporation in general or in the products that we sell. I want to demonstrate that here. We're about an $18 billion company. You can see our footprint across the globe. In our ESG policy, we have three pillars. We have people, we have product, and we have planet. Here we're focusing on planet. Our goal is to have a minimal impact on our environment. That's our pillar, our planet pillar in a nutshell. And it's okay to have a policy, but to have data to back it up. If we use a baseline of 2019, from 2020, 2022, we've had reductions, continuous reductions in our operations, equivalent CO2 emissions. With that, Alan, let's go to the next page, or Josie. We've been involved with emissions reduction for over 50 years. Here locally, I'll focus here in the United States. Our clean air, we've been pacing our customers with the Clean Air Act. And this process, the role that we have in our environment here is facilitators. Our policy is to be flexible, and we set our sales according to what our OEMs want, the likes of Cummins and John Deere and other OEMs. They receive their standards, they receive their criteria for performance, and we see it as our job to facilitate them in doing that. And that's how we set our sales. Our goal is to be flexible, utilitarian, and help our customers meet their demands. And with that, I'll pause.
Thank you, Troy. Our last panelist today is Dr. Adam Schubert, and Adam is a senior associate at Stillwater Associates. This is one of the leading energy consultancies based out of Portland, and Adam has a long and distinguished career in the oil industry, both with ARCO and BP, and has served a number of roles with Western States Petroleum Association and the American Petroleum Institute. So, Adam, welcome, and thank you for being with us today.
Thank you, Alan. Very happy to be part of this distinguished panel today. A quick introduction to Stillwater Associates. We are a consultancy focused on transportation fuels. We've been in business for about 24 years now. Our clients include both fossil and renewable fuel producers, trade associations for the various industries impacted by that, the government agencies, investment companies, and law firms. And the energy transition and regulations concerning fuels and vehicles are a key portion of our practice. With that, my next slide, please. So just like to quickly highlight how we see some of the key challenges for fuel markets. As our earlier speakers have talked about, the demand for fuels is quite diverse, and we need to keep that in mind. Because of that diversity of applications, that diversity of geography, the transition in the fuel requirements for the on-road fleet, whether that's liquid fuels, gaseous fuels, electricity, will change at different paces in different places. And the rate of turnover of the legacy fleet will vary markedly between applications. With that, much of the regulatory drivers for this transition are based on assumptions, particularly as we get into the heavy duty sector and the diesel space, about the pace at which new technologies will become commercially viable for all of the wide range of applications which need to be covered. Because of that, we'll see again a wide range in the need for different fuels to satisfy these, and keeping in mind that solutions that prove to be too costly will deploy more slowly, keeping legacy vehicles on the road longer and requiring fuel for those legacy vehicles longer, making it all that more important that we drive to decarbonize the fuels for the legacy fleet that's out there and will be out there for a very long time. With a key aspect of the fuels industry is that we're not only have to look at what's required for new vehicles, is that fuel suppliers need to supply all of the vehicles, legacy and new, for as long as they're on the road. And so again, driving to reduce emissions from the fuels used by legacy equipment, and providing solutions that at a cost that will help facilitate buyers of new equipment to be able to be confidently purchase that equipment, knowing that the fuel or energy that they require will be economically and reliably available in the region where they need to use that equipment. Last point is that while today's focus is largely on diesel, the three key internal combustion fuels, gasoline, jet, and diesel, can't be looked at individually. They need to be looked at as a group, as a large portion of all of these modes of transportation will be petroleum based for many years to come. Petroleum refineries can only vary their mix between these fuels by relatively small amounts. And in a shrinking market, refiners will be very reluctant to invest to materially change the configuration of the refineries as regulations are driving a downward demand for all petroleum products. Further, we need to coordinate that with the rollout of low carbon biofuels to enable the transition and to enable reduction of emissions for the legacy fleet and new internal combustion vehicles, which will be coming into the market for many years to come. With that, Ellen, back to you. Yeah, I'm not hearing you, Ellen.
Sorry, thank you, Adam. And I see we have a very healthy Q&A going on in the chat right now. I just want to encourage you to submit your questions for the group, and we'll get to some of those here as we move ahead. Our first topic for discussion is the markets for internal combustion engines and fuels. And we've asked our panelists today to consider these and other aspects of that question group. What about the future markets? What are today's markets? What's going to drive folks toward or away from internal combustion engines? And to kick us off with that, I'd like to ask our two OEMs, first Cummins and then Deere, to share some insights about what they see as places where these technologies for internal combustion engines will continue to play a role and where others might come in. So Kathy, let me ask you to kind of kick us off with our first discussion segment.
Absolutely, thank you. One of the challenges we have is that the markets that we serve and the applications that are in those markets are extremely diverse. And so that makes it quite challenging to achieve zero emissions. That challenge is great. From an engineering and technology standpoint, it's exciting as well. So this is a great time to be a technologist. What you're seeing here, viewing here, is an illustrative chart, and it shows the wide variation of power needs and the hours of operation. And those are what are on the axes. Just for reference, there's passenger car there, which is outlined in blue. So if we look at the applications, and let's look at the sort of the corner applications, and if we start at the left, low hour and high power needs, in this example, a lot of those are around emergency operation, whether that's a fire truck, that needs high reliability, or at a higher power node, emergency standby generators that power sites like hospitals and airports. And then if you follow me and start viewing towards the right of the box, we see applications that run high hours of operation. Those tend to be in freight transport, like on-highway heavy-duty trucks. And then if you continue to move up in the power spectrum, we start entering more of the 24/7 type operation, like transoceanic shipping, where it's an application in which losing power in the middle of the ocean becomes a significant safety issue. And as your eyes move more towards the top quadrant of this chart, of this illustrious chart, we have ultra-high power applications like freight rail, like continuous and prime power generation, and powering enormous mine trucks that haul 400 tons of material. In addition to this wide variety of power and expected operational uptime, the environments in which all of these operate are different. Some can be extremely remote and very difficult environments like high altitude, high ambient or low ambient temperatures. And associated with that uptime challenge is then the availability of the energy resources. And those energy sources at those sites can be in the form of fuel or electricity. They need to be reliable, cost-effective, while meeting our customer sustainability goals. And that in itself is a significant challenge. So addressing these wide ranges of applications, they require multiple methods and multiple technologies. And I think this is one of the themes that's coming across in this panel, is that a single solution, it's not going to win in these really hard-working, hard-to-abate sectors, and we need optionality to be able to address our customer sustainability goals as well as their own business goals.
Ellen, you're on mute.
I'm having trouble with that today. I apologize. Pierre, I think Deere has some perspective on that as well. Can you share that with us?
Sure. I think first I will echo what Kathy said on the diversity of product, and Deere is involved in several business. We have a narrow scope compared to the scope that Kathy just described. We are really in farming and construction, but we are also in turf. So we have product from 20 horsepower to 900 horsepower, and all of them have a different challenges. If you can go to the next slide. So the way we are seeing our answers to the commitment we made to reduce by 30% our emissions is really to first focus on different segments. First, we want to be very clear, we believe in electrification. I think electrification might not be zero carbon today, but have a chance to be. It could be very convenient, bring a lot of value and ease of use for our customer. But as Kathy said, it will not answer all our problems. If you want to propel a 500 horsepower tractor, you need 4 tons of battery and you need maybe a couple of trailers to locate them on a vehicle. Not just to the mechanical, electrical, energetic characteristic of the battery, but just the physical room you need to package that. So we really want to focus our battery, and we believe the threshold is around 100 horsepower, 120 horsepower vehicles, where below that we have a chance to move to a full electric and do that in a quite a viable way. Besides that, I think we have to consider a lot of various options. And that option is based on technology and fluid available. So we believe that there is a room for a diesel engine, internal combustion engine, they're continuing to improve the efficiency and reduce the fuel consumption. There is a room for renewable fuel, renewable diesel, ethanol, biomethane, hydrogen. It won't work on every application. It won't work for every geography. You know, just the volume you need to store hydrogen in off-highway environment is huge. getting that available in the middle of a farm in North Dakota might not be as easy, but it must be much more easy to get renewable diesel or ethanol in somewhere in the Midwest, in the middle of a farm. And then we also believe that hybrid for some application with high transient, with high load, or some transportation part of the mix of things the product is doing, have a big opportunity. We demonstrated on an articulated dump truck or loader that we can, with a full hybrid vehicle, get about a 25 to 30% fuel economy. So when we talk about the power system within a vehicle, then we had more constraint than just the fluid itself and the power itself. I want everybody to also notice on the right-hand side of this slide on how we are approaching it, because we are committed to reduce emission, but it should be something economically, technically, and operationally viable for our customers. One, we need, for sure, we need to develop a technology that will really, on a life cycle analysis standpoint, reduce the CO2 and the footprint we have. But that should also meet the customer need. When you're plowing in the middle of the winter, you're doing that for 8 hours in a row. A farmer, when you're in the middle of a harvest, you get 10, 12 hours continuous work of harvesting. And if you early or late, you can lose the value of the crop. You cannot stop for hours to refuel, or every 2 hours have to refuel. And that needs to be economically viable. It needs that our customers want to keep selling their product, their grain, or be able to gain a work site by having an energy cost and a total cost of ownership which is relevant. And currently, something like hydrogen is about 5 times the cost of diesel, and the cost of installation of a fuel cell 100 engine is about 6 or 7 times the cost of in a given application. It may be a much better story for a train or a barge or a stationary genset, but for our application, the cost of packaging and the cost of getting green hydrogen available is something that won't make that available today. So we have to consider within the equation that on top of a CO2 reduction, we have something which is technically, operationally, and economically viable for our customers. And is why we believe a large part of our application will still be in a foreseeable future propelled by internal combustion engines.
Thank you, Kathy and Pierre. Those, I think, really help frame this discussion about, this is not a one-size-fits-all challenge that we have, and companies want to provide a diversity of solutions that are the best fit for their customers. That's really important insight, I think, for all of us today. I'd like to ask a little bit of a shift towards some of the technologies that are coming online to help achieve further reduction in carbon emissions, both on the internal combustion side and others. And Troy, I know Tenneco is a leader in many of these different segments. So maybe share with us a little bit about what kind of technologies you all are working on and see that might help extend the future of the internal combustion engine, make it more efficient and lower in emissions.
Yeah, I can speak to that. Tenneco has literally hundreds of products and tens of thousands of research hours dedicated to the reduction of CO2 through efficiencies, through lowering friction. Sort of on the advanced end of things, we have some research ongoing with bipolar plates and coatings and types of steels and forms. Sort of in our wheelhouse, technologies that we're really comfortable with. We have piston coatings that will help insulate the combustion chamber to keep energy in the working fluid and result in useful torque to the engine. We also have passive pre-chamber work and pre-chamber work that will distribute and normalize and stabilize combustion processes. And we have a host of products that reduce friction, whether it be seals or coatings in the ring pack or coatings on bearings. Also within our clean air group, we have a technology that will help with the control of criteria emissions in a low CO2 mode, where we can use efficient combustion to warm up the catalysts, and then the NOx and other emissions can be reduced. So it's difficult from the hundreds of products. It's difficult to highlight which ones are important. We view them all as important. Again, this is in our role as facilitators. The OEMs have their standards. They have their criteria to meet. We look at it as our job to enable them to do that.
Well, these are some great examples of the kind of technology that I think folks think about in the lab, but really what happens when they get used in wide settings of engines that have greater efficiency, that they have lower friction levels, that they capture emissions earlier in the combustion process. So really interesting stuff there. I want to pivot now to the fuel sector a little bit, and we have the benefit of Neste and Matt's expertise here. And you guys, Matt, are doing really plowing some important ground and have been for a number of years in California. Maybe just give folks a quick snapshot about what renewable diesel looks like and how that helps with the internal combustion engine.
Sure. Yeah. So we're one of the many levers you can pull to get further down this road, right? In addition to all the other stuff the OEMs are talking about. Basically, renewable diesel is a drop-in replacement for fossil diesel because it is a hydrocarbon. It can be used at a 100% blend rate. There's no limits with 5, 20, 50, anything like that. It's whatever blend you want, and you can move back and forth at will. What you see in the left there is a picture of fossil diesel versus renewable. It's such a pure product. It literally looks like water. It's aromatic free, so it doesn't even smell like diesel fuel, whether it's during fueling or exhaust or anything else. And one of the best things, and some OEMs are on the call here, it is OEM approved because it meets the D975 standard in the US. It meets that EN 15940 paraffinic standard, and it can be used at 100% rate. There really are no issues running in these new diesel engines. So having the OEM support behind this really goes a long way to getting things rolled out quickly in the industry. If you jump to the next slide, the big issue here is carbon reduction because that's driving a lot of the progress in the world. And what you see here visually, this is kind of what goes into building a carbon intensity score, a CI score, the LCA, the life cycle analysis that Kelly was talking about. There's a lot of pieces along the way here where there's a difference between renewable and fossil. We're not drilling and fracking for our feedstocks. We're using waste and residues instead, things that have already had their first useful life. Less refining because we're not having to do some of the heavy cracking and other things with petroleum. But the biggest thing here is the carbon that comes out of the tailpipe when you use a renewable fuel like this. It's what we call biogenic carbon. It was already above ground, captured in plants and animals and things. It's not coming from underground sequestered carbon that's adding to the atmospheric load. We're not building up that atmospheric CO2 load. So at the end of the day, depending on the feedstock we use, we're getting up to 75% reduction using our renewable diesel fuel by taking what was basically a waste, a trash product, and giving it a new life. Go one more slide. And the really cool thing, I don't know how many fleet owners and operators we have on the call today, but there's nothing you have to do to change to it because it is fully fungible with the fossil diesel already being run. You're going to use the same fueling infrastructure, the same transport trucks, the same engines, the same tanks. It literally is diesel fuel from a different source. So, we say you can do it tomorrow. We literally mean tomorrow. You could call any supplier of this fuel and start filling it in your tank without even draining what's there before, and start realizing immediate benefits in this regard. You're muted again, Alan.
Yeah. And Matt, is it true that renewable diesel can be used in any diesel vehicle or engine?
Yeah, I mean, it's a hydrocarbon, right? It meets the same ASTM diesel spec that every other gallon sold in the United States meets. Yeah.
So new, old technology can all use it. So that's definitely emerging as one of the hot topics that's going to increase the sustainability, at least of the diesel engine, as we go forward. Just any final comments that folks want to make in this space here? I think some really good starter points, but other comments anyone wants to make?
So just a few points, Alan. When we think of internal combustion engines, clearly most of our focus today is on the diesel platform, but we also think about gasoline. We also think about natural gas. And so just to give a quick review of where we're going in those spaces, within the gasoline world, we're likely to see in the U.S. ethanol increasing to E15, and ethanol producers steadily lowering the carbon intensity of the ethanol they produce through incremental advances in their technology, and also through deployment of carbon capture. There are a number of projects being developed for carbon capture, which basically cuts the carbon intensity of ethanol in half. Carbon capture, I should mention, is also potentially applicable to petroleum refining, again, making a significant reduction possible in the carbon intensity of petroleum fuels as well. Those are both enabled by the recent Inflation Reduction Act expansion to the 45Q carbon capture and sequestration tax credits. Additional areas of in the gasoline space is potentially mandating increased octane. That would largely and most likely, if that were to occur, happen through increasing ethanol content. In the diesel space, as Matt went through, renewable diesel is here today, and what he didn't necessarily make as clear is there are a number of fleets that really do today operate on 100% renewable diesel. Overall, the California diesel market is currently over 30% renewable diesel and biodiesel. So very real displacement. Lot of investment coming into this space, with the petroleum refiners being major investors, including Chevron through their recent acquisition of REG, and a number of refineries converting to renewable diesel production. And also, a potential competition here is incentives that have been put forward for sustainable aviation fuel, which will compete with renewable diesel, likely for conventional feedstocks. And that's maybe something Matt could talk more about on how that plays out, and whether the incentives that have been placed into legislation will be enough. We're kind of skeptical at Scoutwater that will be enough to materially move the needle. But if it does, we are competing for scarce feedstocks, and that's really the challenge for growing renewable diesel is feedstocks, moving past the fat, oil, and greases that are been the low-hanging fruit for technology into more available forms of biomass, which require technology and cost breakthroughs that so far haven't happened, but are definitely out there as potential. One last point I'd like to make is in the natural gas vehicle space, renewable diesel has essentially captured that market virtually 100% in the LCFS markets in California and Oregon, and something like 3/4 of all natural gas vehicles today in the U.S. are fueled by renewable natural gas.
Alan, if I may, a comment based on Adam. I think everything we heard, so that there's a lot of options, both on the technical side, on the power system, on the IC, and on the fluid. And there's a lot of work to synchronize all of it, to make the fluid available, to make the technology available, to make the channel available. So we need the renewable diesel or other liquid fuel or gaseous fluid to be produced and to be channeled, distributed at a point of use where people need it. So it's easier for a fleet, but there's plenty of places where you need to get access to it. So this incentive strategy, this incentive in R&D, or the R&D we are focusing on, and the transformation of the oil and gas toward more bio-based fluid, all of that needs to be synchronized to enable the full benefit of this low carbon transformation.
Yeah, fully agree with you, Pierre. Yeah, what we've seen in the past that the big steps forward happen in when the engines and the fuels are treated as a system, and those markets are coordinated to that's when, if they are coordinated, we can make a big difference. If they're not, those benefits will not be realized.
Adam, you mind if I jump in on the feedstock point you brought up?
Yeah.
You're right. Right now, waste and residues, fats, oils, and greases, that sort of stuff. The oils are primarily what's being used. We spend a lot of money on R&D and future technology development. So we're looking at things like municipal solid waste, lignocellulosics, which would be crop and forestry waste. The barks and branches and husks and things. Also algae, the artificial photosynthesis side of things. There's a study that showed that by the year 2040, the current feedstock pool will probably get us to about 50 million tons of product per year. But if you start adding on the novel vegetable oils, things like camelina and the cover crops not being really used right now, plus solid waste, plus lignocellulosics, that grows that potential by 2040 from 50 million tons up to 250, 275 million tons. So as the economics change and as technology grows, the ramp really expands the further out you get on how much of this we can make.
And I'd say the key step that we haven't gotten to yet is the ability to use the municipal waste and cellulosic materials, which require a very different technology than what you're using today for fats, oils, and greases.
Right.
And it's much more capital intensive, but has more abundant and, in principle, lower cost feedstocks available.
And we are working and connecting our farmers with some of the renewable diesel producers to identify what would be the best cover crop and what would be the best way to harvest and plant and seed all of them. It's an opportunity also for the overall ecosystem, and not to have to compete between the food and fuel, and add some crop, and we could be beneficial for carbon absorption as well. So Can we get a trifecta by creating a feedstock valuable for the industry while helping the carbon absorption of the farming industry and then the revenue of the farmers? So there is some potential trifecta or full benefit that can help the overall industry and also decrease even further the carbon reduction of renewable diesel.
Absolutely, yeah.
Excellent points there. I want to just be mindful of our time, and we're going to move on to the second part of our discussion, which is the policy segment. I do see a lot of good Q&A going on in the chat there, and we'll get to a question or two here in just a moment. But one of the issues that always comes up in these discussions are policies, and we've touched on some of these already. But what is being put in place today, what is helpful and what is not helpful in terms of achieving these goals? And I think it definitely, you all are demonstrating clearly that this is not a one-size-fits-all solution to this complex problem of climate. And but I wonder if our policies are keeping track of that. So I want to just kick off with at least one question for Troy. I know you all have some thinking about this, about how things have changed, and maybe share that with us as a perspective to start.
Sure. Could I just punctuate the former discussion with, there's been some text in the chat about infrastructure before I talk about this policy. I just want to make a point that the three major motivating technologies that are out there, liquid fuel and fuel cells and batteries, they all have their own weakness when it comes to infrastructure, where you're going to get the feedstocks, or how are you going to equip the nation to plug in their cars, or where are we going to get our hydrogen from? There's not one of those technologies that can be favored. They're all equally difficult. We'll leave that now. Let's shift over to policy. I think I'm an old engine guy. Some of us on the panel are old enough to know and remember some of our policies that were enacted back in the late 60s and 70s. We talk about the Clean Air Act. The thing that I see now compared to then, the Clean Air Act methodology was to tell the Cummins of the world and the John Deeres of the world that you have 6 years or 8 years, and then you have to be at this level for emissions reduction, for criteria emissions. And we focused a lot in this space on particulates and NOx and to a lesser degree hydrocarbon emissions. And we just and then the policymakers basically backed out. And then there was a good healthy competition among all of the OEMs to try to get to that level. And it was in that crucible of competition that we came up with three-way catalysts, diesel particulate filters, and a little bit later in the process, we came to SCR that has addressed the NOx emissions. So there's been plenty of good stuff by taking a policy approach that is not prescriptive. If I compare this to the Inflation Reduction Act, and the Inflation Reduction Act, I think, is an attempt to level the playing field. Maybe that's not policy's job, but they have incorporated incentives to drive specific technologies that, quite frankly, may or may not be the solution. We may be well on our way down a technology path that will terminate and not be productive for us as a culture, as a nation. So when it comes to CO reduction, I think a more even-handed approach would be better. I think this idea of it dovetails with Kelly's discussion on life cycle analysis. I think that hand in hand, technology forcing standards and life cycle analysis would be a wonderful approach to the problem. Next page, please. So when we talk about, and I don't want to replow the ground that Kelly's already taken care of, but if we to be fair, there's a lot of uncertainty, and I mentioned this a little bit about infrastructure, but there's a lot of uncertainty with internal combustion engines and with electric vehicles and even with fuel cells and how we address the carbon loading that we're putting into the atmosphere. So we can't really say one is better than the other, quite frankly. So can we wait for these preferred technologies that we see in the Inflation Reduction Act to mature and to grow and to come to a point where they're really effective? Or would it be better to just open up the gates and let all these technologies compete on an even scale and use a measuring stick like a life cycle analysis to do that? So, next step, please. I'm not going to read all this. This actually comes from an excellent article that was published in the January publication of Automotive Powertrain Technology International. Really nice write-up on all the different problems, the idiosyncrasies that come along with life cycle analysis. Is well done. So in this publication, there were a couple of points that I wanted to make. The arguments that I've heard traditionally when I talk about life cycle analysis with OEMs is they feel they may have to put too much on the table. They may have to expose too much of their secret sauce or their IP, for example. But there is a way that can be managed if they self-certify and then there's an auditor involved. You can keep secrets. And I wanted to point out that there's no shortage of work on life cycle analysis. I don't think it's anything that we can put back in the bottle. The life cycle analysis genie is out. There's a lot of independent initiatives through Green NCAP. There's some automakers are even leading the way. Polestar out of Sweden is aggressively pursuing LCA analysis for their vehicles. The governments are involved. We have Japan, and we have the call for standardization within the European Union. So we have to come to grips with the life cycle analysis. I think we really need to standardize. You can get nearly any answer you want, depending on what your bias is. So that standardization is really important. We have here in North America, we have a homegrown version of life cycle analysis that's managed by the Argonne National Laboratory, where they are continually updating their model using the latest information. If we use said model, we did some work here with Inteneco and developed a greenhouse gas factor for these different fuels, these different energy sources. And I won't go through all that in detail, but it really sort of resets the playground, if you will, with what energy is best to use and how quickly we can implement it. And with that, I'll pause.
Some excellent insights there, Troy. Thank you. John Pinson, I wanted to come back to you. I know you've been at this a long time, and your career has been right there at some of the major inflection points of emissions and regulatory policy. What is your take about what's worked best, and what do we need for policy going forward for the internal combustion engine?
I would first of all wholeheartedly agree with the comments of Troy. We are certainly in an era of very rapid innovation and change in powertrain technology. It's very exciting. There are some very promising things happening in fuels and even in electrification itself. And there's a great temptation when there are a lot of early signs of progress to pick a horse, pick a technology. But if we look back at history on successful and unsuccessful regulatory efforts, those that have been far more successful than those that regulate well-considered targets that are based on outcomes which are important to us. And, carbon is our enemy of the day, and I think a carbon-based regulatory measures, which are well-considered, would do much more to drive innovation. And then let's let the market innovate. And certainly, as the speakers have already stated well, there are a lot of different use cases out there which are not going to electrify quickly, and possibly you could make the case that in some cases it's never going to be practical. And so I think that a regulatory policy which drives us towards a lower carbon future would be a lot more successful, because then each use case could then innovate for what is most cost effective, what is most useful to the end use, and what is acceptable to the customer.
Some great points there, and I want to turn to Kathy and Pierre. As global manufacturers, you're looking at all of these challenges for your customers around the world. What do you think industry needs in terms of policy going forward to help achieve our goals for society? Kathy, let's start with you. Maybe you're on mute.
Sorry, Alan, did you say with me?
Yes.
Okay, thank you. I would say what would be most helpful, I don't know if I would put this under the policy umbrella, but minimally guidance on a common methodology and process that also includes responsibilities for determining the life cycle CO2 impact of a project or site or whatever the measure may be. And this process needs to be able to change over time. So for example, if the electrical supply changes, how does that get incorporated into the methodology and then the final process? Also, could that common process detail an independent body that's responsible for reviewing these submitted CO2 emissions assessments? That would be very helpful. Ideally, particularly for those of us who operate globally, ideally that process and methodology, if it could be harmonized globally, would be extremely beneficial for us. Areas where policy are not very, may not be very helpful or least helpful we've already discussed this, is where there are policies that appear to dictate technologies. We've shown earlier that there are way too many applications that we served, a lot of different power needs, loads of different duty cycles. And in order for this to be successful, those markets, even though there's a lot of uncertainty, around infrastructure and what's the best technology moving forward. One thing that is certain is these markets know how to run their businesses efficiently. So for success, we need to be technology neutral, yet performance-based, and having policies around that would be extremely helpful as well.
Good insights there, Pierre. How about you?
Yeah, it's very similar, I think. When you talk about policy, about regulation and incentive, we need to regulate on the outcome, not on the technology. I think target the outcome, get a standardized way to evaluate and assess the outcome, get the performance and a life cycle assessment, CO2 reduction, very clear target, but not dictate how to get there. What we need is get some incentive. We will get the synchronization of the different initiatives, but we have quite a strategic way to approach it. And I think this harmony being, my fear is not even on a global basis we can reach some different target, but maybe within the US, if CARB is going its own way, and then with California another way, and then Pennsylvania follow, but not all the states are following it. I think we really need to get an alignment there. And obviously, if we can get something across different continents between Europe, China, and the US, that will be best. So I think the ban is the wrong approach. I think we have to trust that the players will do everything they can and everything they need to do to make it happening. And a ban is maybe a mindset we had in years when we need to force the transformation, while it's very obvious that everybody is really looking to go into this direction. And so getting an outcome target, getting a way to measure it is I believe, the best way to have a policy.
Thank you. I want to bring in our fuels experts here. Adam, your consultancy and expertise at Stillwater gives you a real inside look at how policies are working. I want to just focus for a minute on the fuels side of this. How is the fuels policy we have working, and what about the low carbon fuels standards and policies that are in place? Are these the kind of things that we need more of, or how should they be changed?
Yeah. So as Pierre talked about, in case we want to focus on what's the outcome we want. We want an outcome of lowering carbon emissions, and the more flexibility the market is given in order to achieve that goal, the lower cost and the less disruptive that transition may be. Looking at specific policies, we have federal policy, particularly the renewable fuel standard and incentives for electrification that work in one specific direction, while we in California and Oregon and now Washington next year and potentially more markets, we have low carbon fuel standards that work quite differently. What we've seen with the low carbon fuel standard is it's been very successful at getting that first round of decarbonization. There's been substantial reductions relatively quickly at a cost. None of this happens without cost, but it's been non-disruptive to the market. The question is, how far can that go? Because what a low carbon fuel standard does is it compels fuel suppliers to supply a low carbon fuel. Requirements for new vehicles require OEMs to sell specific technologies. Neither of those policies force vehicle owners to buy new vehicles of any given technology. And so you have a risk for a mismatch, which can run into difficulties as we seek deeper and deeper decarbonization. We have the risk of fuel and vehicle policies getting out of sync. And when that happens, the regulators have to step back, potentially after substantial investment has been made by all regulated parties, and the desired ends are not achieved. and it becomes more difficult to continue progress.
Mm-hmm. I want to bring in a question here from one of our participants, or excuse me, one of our viewers. Since we're on this topic of fuels, and the question is, considering e-fuels, what's the panel's thought about e-fuels? And also, they're interested in some more commentary about hydrogen, methanol, ammonia, et cetera. We didn't hear a lot about that. Does anyone have any feelings about those?
I may have few comments, but that's my answer will be limited to my industry, so it doesn't apply, I think, holistically. And I'm a true believer that some fluid will be more dedicated to one industry compared to the other. I believe ammonia, hydrogen could work. Ammonia could work in the shipping industry. It could be something that could be produced quite easily around the world, close to, Suez Canal or place like this. While it is not a very good fluid for mobile equipment with a high energy density or high power density, for sure. So liquid fuel, ethanol, we believe ethanol can play a role. I think ethanol is already produced, maybe made available by the conversion of passenger car to electric car. So we may have some ethanol available. It's a pretty good feedstock when you use corn. The energy per acres is pretty interesting, or sugarcane in South America. So there's some value of getting some ethanol. So we see renewable diesel, ethanol being potential fuel for our industry. Gaseous fluid are very hard to package. The volumetric density of biomethane or hydrogen are very low. So very, very hard to package, so very low running operating hours, or you have to compress it or liquefy it, which make a ratio energy on energy pretty unfavorable. So that would be my 2 cents for our industry on this biogas fluid.
If I could chime in here, hydrogen is an interesting fuel. And the reason for that is it is abundantly used for other processes beyond fuel. So there is already an existing infrastructure for certain industries that use hydrogen within their processing. So that makes it a very, very attractive in terms of availability of an existing infrastructure. Now, when it comes to the power density, like Pierre was talking about, there needs to be further development, but this is also where the technology neutral statement comes in. If you have a portfolio of technologies, you can design a system. This becomes now a system issue. Design a system to overcome the detriments or the disadvantages of one particular component technology. So for example, a hydrogen engine paired as a hybrid can overcome, depending on the use case and the duty cycle, be a very good match. In other instances, a diesel hybrid could be a very good match. So when we look at these solutions, and this is why the portfolio of technologies are needed for that system level, and therefore a technology neutral approach for policy, we have to be able to provide solutions that meet the end customer needs. And sometimes it comes down to certain markets are just driven by operational cost. That's going to drive one type of technology. And there are others that need high reliability and 24/7 operation. And they're not necessarily driven by capital costs of their equipment. So the portfolio of technologies, and again, being technology neutral, is very important to be able to make sustainable gains in greenhouse gas reduction.
Right.
I just want to jump in and kind of echo what Kathy was saying. The technology agnostic portion, I know Kelly says that a lot too. It's not just on the hardware side, it's also on the fuel side as well. I mean, if the goal is net zero, well, there are some, renewable natural gases and things still used in internal combustion that are negative carbon intensity. And with regenerative agriculture and other stuff, you can get near zero with some future technologies on liquid renewable diesels and things. So if the goal is just zero carbon, kind of like Kathy was saying, we really need all the options available rather than kind of putting everyone down one path, down one funnel and hoping for the best, right?
And if I could just jump in, you really need to tie that back to the regulations again, because if we simply look at the tailpipe as our way to measure emissions, right, then we're going to lose the advantages of things like renewable natural gas, potentially renewable diesel. So we have to kind of look at this life cycle analysis approach, if you want to call it that. I will say life cycle analysis, though, is also not the silver bullet in the sense that it's a very hard problem. It's very hard to get it right. But I think there needs to be a lot more focus on getting it right. There needs to be a lot more research funding and things like that on coming up with these standards, because I think it's critical. So really all of this comes back down to, we need a diverse portfolio of solutions. And in order to allow us to get there, we need technology neutral regulations.
I'd just like to say that
on top of that, we need technology neutral incentives as well.
Yeah, absolutely. Yeah, they're just two sides of the same problem.
Right, and to speak more to what Kathy said, as a component supplier, a change in fuel for us in an internal combustion engine only represents a change in it's the same theme, it's just a slightly different tune. We have over 7 different fuels that we're running right now. To learn what are the idiosyncrasies of these fuels. When it gets right down to the combustion process, we'll take, for example, hydrogen. Hydrogen on an Otto cycle, not a diesel cycle, but hydrogen on an Otto cycle, the flame speed becomes your friend, because when you get that constant volume pressure rise, that means pure efficiency. So having to manage that becomes a challenge. Hydrogen will light off on nearly any hot surface you have in the combustion chamber. So then it becomes our parts need to manage hot surfaces. So for us, it's a variation on the theme. Really, we just need to make our mind up and get started down this process, and begin to bring all the technologies that are important in this sector to bear. And having that open competition is really important to us.
I heard a lot today about there's some very simple concepts about time and space, and I wanted to focus on the time aspect here a little bit. I think one of the things that can be frustrating in some of these discussions is that we have a lot of looking out well beyond the headlights, as you might say, which is establishing that in a certain milestone, 2035, 2040, that something will happen. And it seems like until then, there's maybe not a lot of thought given to what should be happening. And I wonder if we're appropriately valuing what different solutions can bring in and the time that they can bring them. So what do you all think about this notion of time and some of these near-term opportunities? I think this is where internal combustion engines get maybe kicked to the curb a little bit, because they're so expansive that making adjustments, minor adjustments even now, could result in tremendous gains for however long it takes for whatever transition is going to happen. But what do you all think about the time issue? And we're getting close to our end of time for our session today, so maybe this will be where we end. But let's hear from you about time.
Yeah, so to address time, I think the life cycle analysis is the tool. Now, because then you take care, you're considering the carbon footprint to get the fuel to you, right? And in that context, then you can talk about the benefits of the internal combustion engine, because when you end up with a potential drop in fuel and we have the infrastructure, then bang, all it takes is the shipment, and then we're running. But if you only look at the local emissions on the vehicle, then this argument is not as strong.
Yeah, the other element of the time question is thinking about the atmospheric lifetime of CO2. It's that once we generate it, it's there for a very long time, and that gives us the urgency to get greater reductions today. Getting greater reductions today means decarbonizing the fuels to the existing fleet and the fleet that will be introduced in the next few years, rather than waiting for new technology to solve the challenge for us.
And,
Yeah,
and
I like
Alan,
it.
one of the ways
Go
that
ahead.
I like to think about this is time value of your carbon reduction. And so just like with money, $1 today is often worth more in terms of its overall environmental impact than like $2 and sometime in the indefinite future. I mean, I think that, really the power, the carbon reducing power of making rapid incremental progress through fuels and through engine innovation will bring us tremendous benefits. And we should do that while also working on the others.
Matt, I wanted to just call on you. I know we had talked about this in a before, but we're looking at these different solutions. There's a gap that's here, and what can help fill that?
Yeah, I mean, real quickly, if this entire page were the global oil demand for everything, what you see in the boxes here is for transportation, and out to 2040, the projected EV growth plus the projected biofuel growth, there's still a gap in the middle there, right? So this is just, it's hard evidence from international organizations about the fact that we need all solutions. And in the middle here, you'll see e-fuels and hydrogen and other stuff to come fill the gap. But yeah, before we run out of time, the big picture here is we really do need everything to fill in all these boxes if we really want to reduce carbon and start reducing the fossil dependency.
Anyone else?
Add just a little bit to, yeah, if I could add a little bit to that, Alan, maybe tie it up with a bow here. The decarbonization journey is as important or maybe more important than the destination, right? In my view. And so it's okay to have a solution out there, a perfect solution that we're heading toward 2050, renewable grid, all electric vehicles. But, we need to be doing everything we can today, as everybody has already said, to get there as fast as possible. And so the journey is as important as the destination, maybe more important because of the time value of the CO2 reduction, as John said.
And one thing I think we should really consider that IC is part of the solution, not really only the problem. And I think it can play a significant role in helping. The journey and destination, I think, is a good analogy, but you can also have a more mathematical analogy between the line and the surface. I think we need to address the surface, which means the fleet and everything we are going further. And this is, we have millions of vehicles on the ground, and this one can be upgraded, could be transformed with fluid, and then continuing to work on a mix of solutions to address the lack of feedstock down the road, and then leverage all the innovation, both in electrification, in hydrogen, in a different fluid, e-fluid down the road, with a different time horizon. But we need to make sure, with the urgency we have on global warming, that we take every option to decarbonate and not dictate all things through a more mental mindset.
Okay. I have an interesting statistic that is really apropos here. So there's a gentleman by the name of Dr. Olaf Toter. He's part of the KIT Institute out of Europe, out of Germany. He makes this statement. He says there are approximately 1.4 billion vehicles with internal combustion engines on the road today, globally. And in 2050, there'll be 1.4 billion vehicles on the road. That's even with alternate technologies penetrating that market. So the question is, can you really not address fuel? Even with the growth of alternate technologies, can you really not address fuel and expect any big impact on the carbon load that we're putting into the atmosphere?
Well, I think that's where we'll have to end it today. I think we could go on for an almost an indefinite period of time with this conversation because of all of you and these really insightful remarks and perspectives that you're bringing to everyone here. And I do appreciate the great responsiveness in the chat room here. Lots of back and forth during our presentations and discussions today. But I think some of the takeaways are ones that maybe are again simple, that there is a time value on carbon, and internal combustion engines do have a significant role to play in our decarbonization journey, and we ought to be mindful of that and work everything we can to optimize that through the use of these cleaner fuels and these continued advancements in internal combustion technology, which is, it's not a technology standing still. there's more good things to come, and that's good news for all of us. So I want to, on behalf of the Diesel Technology Forum and all of our panelists today, thank you all so much for your time in helping prepare for this session and participate. You truly are leaders in all of your segments. It's really great to have your insights. And for our audience, thank you for being with us. We know that we're in a crunch time of the year. Everybody's finishing up things to get away for the holidays, so we respect that. This recording will be available to you, as noted earlier, on the DTF website, and you'll get a link because of your participation today. But thank you again for your being with us. We have a newsletter if you'd like to join to sign up for that. We invite you for that as well. But with that, I'll wish everyone a good day, happy holidays, and again, thank you for your time today.
Thank you.
Thank you.
Thank you.
Thanks, everybody.
Thank you.